I'm Bob Bill with Co-Orchard Equipment. Today we'll be talking about maintenance and operation for your Co-Shaker. So first point we're going to talk about today is we're going to talk about our sweepers. Sweepers should always be set with a pitch from front to back. We want the back side of the sweeper to clear the ground and the front side of the sweeper to be touching the ground as light as possible and still be able to clear the path for the tires. When we're talking about maintenance on our sweepers, we also, as the sweeper wears, we're going to want to maintain our height by lowering it. The other thing we want to do is we want to maintain debris from coming in between the motor and the motor plate. What happens is that tree rope can get in there, and what it'll do is it will chew up the shaft seal and ruin the shaft seal and create a service issue. So again, we want to pitch. We want to pitch towards the front, light contact. We want basically contact that's wider than the tire. Rotation for the front sweeper should go away. Rotation for the left rear sweeper should go away from the outside or towards the inside of the machine as well. And then your right rear sweeper should go in towards the machine. Grease points on the sweeper include the pivot pin, the lift pivot pin, and the sweeper. All those are basically a weekly service point. We should be servicing lift cylinders, roll cylinders, steering cylinders, and steering knuckles daily. Okay, so now what we're going to be talking about is our water tank and our maintenance in the front of the machine. Depending on the style of the shaker, you're going to have anywhere between a 25 to a 30 gallon tank in the front that is going to require anywhere between 1.5 to 2 quarts of water-based silicone per tank. In our tank, there's a couple of areas of maintenance in our tank. One, when we're done filling the machine, we want to make sure that our cap is tight so we don't get dirt inside the tank. Secondly, if your tank has a gasket or a seal, you want to make sure that the gasket is not torn or cracked or broken or missing to make sure you maintain sanitation in the tank. If the tank gets full of dirt, then that can create problems downstream and affect the performance of your water. Another service note here is on a majority of machines, your intake is here. So when we're done filling the machine, try to avoid washing off the top of the tank and getting the pre-cleaner dirty or wet. If we get the pre-cleaner wet and then we start to drive, we get a lot of dirt in here or dust in here and it creates mud and it will inhibit the ability of the pre-cleaner to perform its job. As a part of winter storage, what I recommend doing is taking a small container of 2% bleach solution, placing this inside the container and cycling the machine, water cycling the machine. What that'll do is it'll run that through the system and it will clean the lines and keep you from having algae buildup over the winter. The other thing too is to make sure that when you're done with winter storage that your tank is empty and clean. Don't leave the silicone solution in the tank over the course of the year because that will also build up a lot of things that can cause service issues and inhibit the performance of the water system. So now what we're going to do is we're going to talk about maintenance behind the cab. First part of maintenance is underneath this plate here on a majority of shakers is your cab pressurizer filter. This is the main unit that draws in the air, and in between there's a filter. The filter that is underneath here is a non-serviceable filter and should be replaced once a year after season, prior to season, or after season or prior to season. Also, over here on this model, we have our air filter here. Depending on models, your air filter could be placed here or it could be placed over the rear of the engine. The general service points on the filter is we want to make sure that when we open up the filter and remove the filter, we only ever maintain and clean our exterior filter. The interior safety filter should never be serviced. It should only be replaced. It is recommended on your main filter service to knock off the filter and not to blow it out, for fear that you could cut or tear the element on the inside and cause yourself a engine issue. Other notes, depending on the model, typically we are using this side of the machine for air intake, for charged air coolers, in this case a condenser. So it's a good idea to try to maintain sanitation in this general area. In other machines where this door is not open and serviceable, making sure that we blow this off on the interior of the screen, keeping the screen clean, so that way that the condenser and the pieces in here can actually get the air they need. The other thing that we want to do, because of the way the air comes into the side of the machine, is we want to limit the amount of storage that we have in here. We don't want to see slings, flaps, toolbox, lunch pails, things like that that are sitting over these intake screens and inhibiting the airflow going through either the condenser or the charge air cooling system. Another note on all the R series, a majority of our electronics is over here in this corner. We want to avoid pressure washing this area with high pressure water. The other thing of note is if we should have to weld on a machine or work on a machine that fashion, it is crucial that we disconnect both the Botus ECU and the John Deere ECU. Depending on the type of the machine, all of our R series shakers use an AW46 hydraulic oil. Typically the fill mark is indicated on the outside. So right now we have a cold fill, and then we also have a hot fill. You can expect to have the oil level raise or lower depending on the temperature of the oil. What we want to avoid is when the oil temperature is high, filling to the high mark, because what will happen is the oil will expand and then it will go over the cap and will spill oil. On earlier machines, non-R series, the oil we used to use was a standard 15W40 oil. Both oils are a synthetic oil. So you can add an oil, but just make sure when you add your oil that it is not a synthetic oil. We don't want a regular oil and a synthetic oil. They don't mix well. So again, R series, we use an AW46, and prior models, prior to 2018 non-R series, they use a 1540 for hydraulic purposes. So now we're going to talk about service and maintenance in front of the radiator. Depending on the model, we can have anywhere between, we can have a condenser, oil cooler. In this case, we have a fuel cooler, oil cooler, and then the radiator charge air system. So all these components are designed to be able to be pressure washed, but they're only recommended to be pressure washed as a end of service maintenance. What we were trying to avoid is people putting water there, driving it into the field, then you have water, you have dust, creates mud, and then you can create a larger service issue. Whenever we're dealing with the service points, all the service points swing out for easy access, so you can blow from the front and the back side of the radiators or oil coolers, condensers, etc. On older types of machines, we used to have a fold down. On the fold down, where we have a two-piece, right in here we had the hoses for the air condenser. What we want to do is we want to avoid using those air condenser hoses as a handle to open and close it. What that'll do is it puts stress on the condenser, and you can break the top of the condenser and create an AC issue. Regardless of the type of oil cooling mechanism that we have in the front, make sure that when you're done with your service that all of your locking points are in place and that the oil cooler, condenser, fuel setup isn't able to move, and that everything is rigid when you're done with your service, to avoid having these pieces make contact with the radiator and create a service issue. So now what we're going to be talking about is we're going to be talking about engine service on your shaker. Fuel filter service should be done annually every year, including crankcase filters. Crankcase filter service should be done every year. Oil service is a little bit different. Oil service, if you receive a brand new machine from us, your machine will come in, your engine will have a break-in oil in it. That break-in oil is required for you to change at the onset of 100 hours. So within the first 100 hours, we have to remove that oil and replace with a compatible oil. If we're dealing with a newer Tier 3, Tier 4 machine, Tier 4 machines usually require a low sulfur oil. Older sub-tiers, Tier 2, Tier 3s, can use a regular 5W40 or 1540 depending. And typical intervals for us is every 250 hours we'd like to see the oil change, oil service happen after that initial 100 hours with a brand new engine. Another thing that we're going to talk about briefly is our water and our antifreeze. It's recommended that every 2 years that we change out our water antifreeze due to depletion of additives that are beneficial to the engine. With new shakers, it's always a good idea to make sure that you double check your torque or your tension on all your lug nuts, depending on style, especially within the first week after a purchase of a new shaker. As seen in the picture, another part of note is our hubs. In our hubs, you want to make sure that you replace the oil in the hub every year or every 500 hours. It should always be filled to basically the halfway mark. We use a 90 weight synthetic oil in the hubs to prevent gear noise. As additional note, typically we want to maintain no less than 60 psi in our tires. So periodically checking our tires for proper inflation will keep us from having future tire issues. Now we're going to be talking about oil filter maintenance. On an R series, our return filter should be done basically replaced every year. The charge pressure filter on the hydrostat should be replaced every year as well. On other models where we have an independent charge pressure filter, the same rules apply. The in-tank suction filter should only be done as a replacement due to contamination. On older non-R series shakers, the main Schroeder filter should be inspected yearly, but basically replaced every 1,000 hours. General maintenance inside the shaker, we should always try to maintain a level of sanitation inside the shaker, whether that's washing the machine off a couple times a week or even blowing the machine off at the end of the day. We really want to avoid accumulation of leaves and dirt and debris that can potentially become a fire hazard. Also, when we're talking about hoses and should we have a potential leak, never check for a leak with your hand. Never, for fear of having oil be injected into your hand and cause a severe medical issue. So whenever we do have a oil leak, we want to make sure that we address that oil leak promptly and clean up afterwards to reduce the potential for a fire hazard. Depending on your shaker type, you're either going to have a water system here or a water system against the front firewall. The water systems that are electric water pumps, have an incoming filter. It's important to make sure that you change that filter or clean that filter every year. Here, when we have the more traditional water system with the hydraulic oil or the hydraulic cylinder and the water cylinder, we want to make sure that that water cylinder is free of movement, free of debris. Also note that when the machine works automatically, it does stroke, so make sure that the door is closed and your hands aren't there. On those models, there is a small spacer. That spacer is cut by Co, and that is our balance between pad life and tank life. It's recommended to, if needed for more water, to cut that and give yourself more water, but it's never recommended to add space to that and reduce the amount of water. On our R series, typically the amount of water that we want per tree is usually right around a second or just under a second, and that's adjustable through the screen. It's always important that when you're putting fuel in your shaker that you use clean filtered fuel, as well as on our series or higher tier 4s, we want a low sulfur oil. With this, we want to make sure that we're filtering at every step. So if we're putting our fuel into a fuel wagon and from the fuel wagon into the shaker, we want to make sure that we filter that fuel at every step. As the tier level on the engine increases, the requirements for cleaner and cleaner fuel gets higher and higher. Now we're going to talk about our pads. Our pads are the most important barrier between the shaker and the tree, and protecting the tree from the energy that we're providing to try to remove the nuts. Our key components are our flap, water manifold, and our sling. As the machine starts to wear, what we may notice is our sling may get longer and longer. If the bottom of the pad begins to droop no more than about an inch or so below this, and our pad can no longer maintain its position behind its rest, it would be necessary for us to replace our sling. The flap is what makes initial contact with the tree. So as it makes contact with the tree and it starts to wear, we want to replace the flap prior to it starting to make damage to the sling. Also, with our pads, we want to periodically inspect our pads to make sure that our pads don't show any indications of breaking, blistering, deformation. If we do start to get some deformation on our pads, and it's typical to have one side of the pad start to go concave, it's a good idea to rotate the pads. With filled pads and water, what we typically recommend is just to rotate it every time that we're servicing our sling and our flap. Another key part of our pads is our water flow. We need to make sure, in order to keep our pads cool, we need an even amount of water flow between the two pads. For sake of argument, if we had more water flow on one side and less water flow on the other side, then typically what we can do is adjust the tension of the bolts over the side that has, say, excessive water flow. We adjust this tension. What that does is it builds pressure here and it will force more water to go to the other side. Typically we want equal water flow between the two sides, but it is preferred to have more water flow on the stationary side of the head. The stationary side of the head has more energy and typically has more heat in it. So inside the shaker head we have a couple key components. First component is our rear drive sheave. Rear drive sheave should be the proper drive sheave for the crop that we are currently shaking. Typically with almonds, it's a larger drive sheave by comparison to a walnut drive sheave, which is typically smaller. Right here is our reversing idler. Here is our alignment idler. This is our V wheel, and then this is our flat wheel. If the shaker is outfitted with a greasable bearing, as shown here, we should grease the wheels once a day, 2 pumps per wheel with this grease, which is available through Co or any Co related dealers. And again, we are 2 pumps per Zerk every day. Now we're going to talk about belt tension. So a new belt, whether it's done as a new machine delivery or even done as service replacement, needs to be addressed. So currently our belt tension, and the way we check our belt tension was with a thumb underneath the case, and we press down firmly, like a very firm handshake. What we're trying to avoid is the belt to be very, very loose and making contact with the bottom of the case. As you can see here, we do have some indications of some marks. Those are not bad marks. If our belt gets too loose, what will happen is we'll end up with marks in front and below of the tensioner. They're in basically a rainbow or an arc shape. So it really indicates that basically this limiter is keeping the belt in position from coming out to the wall. If we see those marks, we're too loose. So with a brand new belt, typically it's going to come from the factory pre-adjusted. Make a note of that tension so that way you can recreate it. In order to adjust the tension, what we do is we loosen the 4 bolts on the top of the adjuster plate, we loosen up the jam nut, and we basically draw this back. Typically, with the type of belt we're using currently, from a new belt to full stretch, we're typically about a 1/2 inch back on this plate. Will give us the stretch that we want. We've been very, very happy with this belt. It has a 5% grow, and then it actually kind of comes a 10% grow, and it actually retracts another 5%. It's got a good back wall. But again, making sure that we check our tension. The other thing we want to make sure that when we check our tension on our belt is the interval. With a brand new belt, we're going to want to check that belt at least once or twice within the first day to make sure that we're chasing the tension. A key part of that is to make sure that we do it at the end of that first day. If we wait until the next morning when the belt is cool, it's going to give us an illusion of tension that really doesn't exist. So making sure that we check the tension of the belt when it's hot is crucial to making sure that we have proper tension. When we're in here and we're greasing the head, a daily check of the belt is also a good idea, making sure that we don't see signs of fraying, cracking, glazing, anything that could indicate a potential head problem or a belt failure. It's always much easier to replace a belt as a part of service as opposed to a part of failure. And we have potential failures in weights and things like that if we lose the belt while it's at working speed. Another note with the belt is it's typically recommended to replace that belt annually. The belt goes through so many stresses, hot, cold cycles throughout the course of the year that trying to get that extra life out of the belt in the beginning of the subsequent year usually results in a failure. So again, replacing this belt every year is kind of cheap insurance. Other service points in the head include our grease service. Our grease service of our cylinder should be done every day, preferably twice a day. Excessive grease here is not a concern because the nature of the clamp cylinder and how it moves basically hammers out the grease continuously. If we look at this cylinder or even the rear pin, on a normal day, this cylinder is cycling 7,200 times a day. In that regards, grease is cheap. So maintaining grease service here is one of the most paramount parts of the machine to grease, is here and again in the rear pin, our 2 points in the rear pin. So our clamp cylinder and there is really where we want to maintain our grease. Grease is very cheap in comparison to pin failures and cylinder failures. The other part of service that we're going to talk about is our pad tension. These two pads right here, basically these arms, as we squeeze a tree, trees are typically not parallel. Typically there's a small shape to them. So when we squeeze the tree, what it's trying to do is it's trying to take the clamp arm and rotate the clamp arm. So the more space that we give this system here, the more room the arm has to move, the more stress it puts on the clamp cylinder, and the more stress it puts on the rear pin in the back, increasing potential failure. So as these pieces inherently start to wear, all machines are usually supplied with this shim here. So as we start to see a gap here in this area right here, so as we start to wear, we're going to start to see a gap. What we're going to do is we're going to introduce this plate. So what we do is we unpin the cylinder on the opposite side, we bring the arm out, we take this pad off on the bottom, take the pad off, place this against the arm, then replace the pad. And that will take up the resultant gap that we have on the top. So we do that on the bottom, then we do that on the top. And once we've run our course on the bottom and the top and we start to get a subsequent gap, then typically what we do is we replace the parts for new parts and start the process over again. An additional service point is in the back of the head. As we talked about prior, the arms in the front keep the clamp arm from moving. But as we wear, this bushing right here on the top is actually making pressure on the top of the arm. And that's keeping the arm so that way the arm will rotate this way and not this way. So over time, typically about every 100 hours, a good idea is to periodically put a bar underneath the bottom of the case and underneath the arm and actually try to raise the arm. If the arm has any lateral movement up and down, then what we do is we remove the cross bolt on the top, tighten the castle nut, or hammer this piece down and tighten the castle nut so this makes contact and we no longer have lateral movement. What that does is it forces that pin to move this way and not this way, reduces wear. So grease and service on these 3 points go a long way towards mechanically keeping the pieces of the head performing at ultimate levels as long as you can. This is the main energy pin bolt. The main energy pin bolt is not only aligning but maintaining pressure in your bearing system. If this is to come loose, then we can cause a detrimental failure to the pin boss, requiring a pin boss failure. With a new machine, it is recommended to daily check the tension on the bolt, and then after that, a weekly check of the tension of the bolt. We never want to see this bolt come loose or spin. As soon as we do, we need to call and address the situation prior to it becoming a larger issue. The bolt tension here is 700 foot-pounds. For people that don't have that ability, basically by using cross checks or marks on the head will indicate if you have any bolt rotation. If you don't see any bolt rotation, then you should be tight. But as soon as you start to see any signs of movement here, you should address the problem. Inside of our carriage here, we have four pieces of IPX plastic, which is our barrier between our mast and our carriage. On the top we have 2 1/2-inch pieces, and on the bottom we have 2 3/8 pieces, so it's relatively loose. If you can see right here, we have about an 1/8 of an inch gap that we always want to maintain. So as those 1/2-inch plates start to wear, we want to make sure that we adjust these pieces up. So what we do is we loosen the 4 bolts and we adjust them up so that way that the gray piece, the nylon piece, isn't making contact with the mast. If it does, it can potentially break. And as the IPX on the inside wears and we can no longer adjust our height and maintain our height, it's time to replace the IPX. Again, the 1/2-inch IPX goes on the top, the 3/8 goes on the bottom. Another service point is, especially during high defoliation years or mites or the end of the year, depending on where you're shaking, when we run this out and the head is slightly elevated, we're going to begin to get trash and debris inside of this system. And what can happen potentially is we start to get that in there, it starts to mulch up, and what it'll do is it'll start to put excessive pressure around the mast, increase the heat, increase the wear rate of the interior pieces. So periodically coming in with an air gun, extending it and removing the rear cap and blowing the air out of the mast is a good, or out of the carriage is a good idea. Another point is inside the mast. So periodically when you're blowing off the machine, blow air through the mast to make sure that any of the debris that is coming in here doesn't go into the back cap. What happens is it starts to smash into the back cap, it'll build up and it'll actually keep the machine from rolling. Last piece of contact that we're looking at in terms of the mast is our hanger mount tension. Typically we're looking for a relatively loose hanger mount. So the tighter we make our hanger mount, the more shake we have going back into the machine. So finding that balance is key, but a lot of people neglect their hanger mounts, which causes frequent replacement of hanger mounts. Typically, about every 50 hours, we should be adjusting our hanger mount tension once a week per se. And what we'll do is we basically just give these about 1/3 or 1/2 of a turn, maybe a full turn depending, but what we're looking for is a nice uniform compression between the upper and lower washers. We're also looking for freedom of movement in the head. Service here greatly depends on the operation style of the operator. If he's fast, he's quick, he's trying to maybe overextend the use of the machine, then these are going to be worn down much quicker than somebody that's a little bit more temperate paced. So again, making sure that we maintain this. If we don't maintain this and we allow this to move and allow it to rotate, what happens is the bolt will start to make contact and then potentially we can have a bolt failure. We have 2 foot pedals against the joystick. The foot pedal on the left is our direction control. Out is forward, inside is reverse. The harder we push the pedal, the quicker the machine will move. We can also use the foot pedal on the right, which is a hydraulic accelerator pedal. So the farther we push this in, the more oil flow and the faster we go. So in the case of going reverse, we push reverse, we'll start to move. We want to accelerate in reverse, we would push the gas pedal or accelerator pedal. When we're in a manual shake mode, we can use this accelerator pedal to increase or decrease the amount of shake in the head. On the left side of the dash, we have our radio, fan control, 3 speeds, low, medium, off, low, medium, and high. Our air condition control, the farther to the right, the colder to the cab. Heater control, off, on. Also, we have our low oil indicator light. The low oil indicator light refers to the amount of oil in the hydraulic tank. Should we have a leak and this comes on, we need to stop the machine immediately and determine the leak and resolve the issue. First is our joystick. Joystick gives us the ability to manipulate and control the head. The farther we move it, the faster the function. Pushing it down lowers the head, raising the head, extending the head, retracting the head. Clamp, unclamp, roll left, roll right. The trigger button here has two functions. It will change us between an auto and a manual mode. While we're in an auto mode, during the course of shaking or even retraction, if we were to push the unclamp or the trigger button, it will stop the function. Our main screen, upon starting up the machine, you can see we have quite a bit of information here. Lights on, off. This is our harvest or our travel mode. So when the tree is in front, we're in harvest mode. When the road is in front, that's our road mode or high-speed mode. You cannot shake when you're in road mode. You can only shake when you are in tree mode. Parking brake, act on and off. If we want our active brake, we press and hold for 5 seconds. Now our icon turns green. This is telling us that we have an active brake. This is helpful for when we're in hills. To deactivate the auto brake, active brake, we push it, now red is on, black is off. The brake is always on when we turn the machine on. This is our sweeper on and off. Basically, sweepers are down in their travel position, ready to work. Now the sweepers are off in the up position. This is our cab pressurizer here. Cab pressurizer on, cab pressurizer off. This is an indication of a fault code. Here we have battery, oil, engine RPM, water temperature, current shake, clamp pressure, or current shake clamp pressure, engine status. This right here is an indication of our current shake mode, whether we're in an auto or a custom. Currently we're in a custom one. Here is our engine RPM adjustment. So if we push the button, we're going to be either in the rabbit or idle or rabbit. So if we push rabbit, that's going to bring us to our high idle. That's where we should be when we're working. You'll also notice that when we're at our high idle, everything turns green. When everything's green, we're good. The other way we can adjust our RPM is by utilizing the wheel. But again, we're either turtle. If we're moving it around the yard, we have a little bit of RPM. But if we want to go into the field and start to work, we always use the rabbit. This is our blinkers. So the blinkers come on automatically when we're in road mode. When we turn road mode off and we're in harvest mode, they go off. So if we want the rear blinkers and the front blinkers on when we're in harvest mode, we push that button there. This is an indication of our fuel, and this is a rear camera view of what's going on behind us. Now to access page 2, we push the upper right button. Here we have return to home, shake control, rear camera, tree count, shake threshold, operator adjustment, and BOTUS service. We're going to start with shake control. There may be a slight variation here, but the current mode gives us this pattern here. If we touch in control, our first in control, this is our manual control. Our manual control allows us to set our minimum and maximum as it applies to our pedal. So in order to adjust, we push it. You'll see that it's highlighted yellow. The more we turn it to the right, the increased max we have. The more we turn it to the left, the less we have. So if our max is below our minimum, when we set it, you'll notice that our minimum automatically adjusts down. What this does is it sets the threshold for the pedal, for the foot pedal. So right now, if I turn the machine on and I was shaking, if at no pedal depression, I'd be at 24% shake, and when I went all the way to the floor, I'd still have 24% shake. This is a nice way to be able to allow you to control the level of input that your operators have so we don't overrun the head. So in this case, if we go to about 79%, we adjust our minimum up to about 40%. What this means now is when we start to shake, we push the clamp shake, we will start at 40% and we'll have a range between 70 or between 40 to 79% in the throttle. So all the way down on the foot would be 79% and all the way off would be 40%. When we're in this mode and we go back to the home screen, you'll see that we have a M, which is for manual, located inside the tree. Now we're going to do setting up a custom shake. So right now we currently have a pattern in there. What it's stating is we're starting at 40%. Starting at 40%, and then over about 7/10 of a second, we're going to stay at 40%. Then we're going to elevate up to 65%, travel down to 62, down to 44, and then 41% as indicated by the graph. Now, if you want to set your own, this is a preset, but if you'd like to set your own, first we're going to do is we're going to clear. Now that we're clear, so we have a box that's highlighted yellow. We push the wheel in. Typically, we like to start a shake anywhere between 40 to 50%. Once we've set that, we're going to push once it goes green, we're going to push it again, the wheel again. Now we're going to go to our second segment. So this is the beginning of our ramp. So in this case, we're probably going to go up to, let's say, 70%. 70%. Our bottom number is time, as represented in milliseconds. Here in the graph in the bottom, you can see it in second indicators. So in this case, we're going to start our shake in about 2/10 of a second. We're going to go from 40% to 70% and start the tree from shaking. Start the tree shaking. Now the next step we're going to do is we're going to do kind of the meat and potatoes of the shake, the duration of the shake. In this case, we're going to go to, let's say, 80%. And we're going to do that over a period of about a second and a half. So you'll notice that we have a line that's developing that is not flat with the horizon. It has a slight angle to it. Anytime we can develop a pattern that doesn't have flat lines, it keeps the tree in confusion and gives us the best removal in the shortest period of time. Then next what we're going to do is we're going to start our deceleration. We never want to stop our shake at the highest point. We usually want it to decel, for bearing life, belt life, but also tree safety. So typically we're going to end our shake about where we start our shake, typically in the 40s. So in this case, we're starting at 40, we're going to 70. We're going from 40 to 70 at the start of our shake. We're going to run that for about a second and a half. We're going to get up to 80% at max, and then we're going to drop back down to 40. One of the nice things about this feature is if we're shaking crops where we want, like, let's say, like a bump shake, where at the end of the shake we want kind of a very slow, deliberate bump, we can basically make ourselves a additional flat spot at the end of the shake. And so what this will do now is we'll ramp up, we'll shake the tree vigorously, we'll decelerate, and then at the very end, we'll give the tree kind of a violent, slow but violent whip at the end. And then you can increase or decrease the number of revolutions or violent shakes by increasing or decreasing. What we typically look at when we're doing this kind of pattern is when we see a lot of leaves, typically means our pattern is too long. We want to shorten up our segments. If we have a lot of trash or a lot of sticks, a lot of debris coming out of the tree, usually it means that our highest point or how hard we're shaking potentially too hard. We're creating more work for the downstream functions like sweeping and picking up. So in this case, after I shook a tree or two and realized that maybe it was too hard, I can go back to the peak, which in this case is 80%, and I can lower my 80% down to a value where I'm getting optimum removal without removing unwanted trash from the tree. Now, if we're going, let's say we're going too long, then I kind of go to the longest segment, and I can shorten that segment And so now we're shaking with the same relative pattern, but under 2 seconds. If we are in a current shake pattern like this, when we go back to our home screen, you'll see right now we're in a custom one. This could vary. In some models, this could be a picture of a nut, whether it's an almond or a walnut or a pecan. Either way, it's just an identifier of the current shake mode. Next, when we go into the page 2, we look at rear camera. This gives us the ability to basically have a full view of the rear camera, also having some of our other controls. This is a very helpful feature when we're on the road. When we're going down the road, this gives us the ability to have a rear view and operate at optimum safety by being able to see what's not only in front of us, but behind us at all times. Next, we have tree count. This tree count will give you the ability to do not only job count, but total lifetime trees shook. We can clear the job count, but we cannot clear the lifetime trees shook. And job count, this is a good way to not only monitor the ability of operators, but it also allows us, if we're doing commercial work, to actually know how much we shook. Now, in order for a job to count, we have to have a clamp shake, an unclamp, and then we have to have a movement forward. If we sit here and just push clamp, unclamp, it won't work until we actually move forward. So we're only counting the trees that we shook, and then we count once we pass the tree. Next, we have shake threshold. This is where we adjust our clamp pressure. So in this view, you can see that we have a couple different icons. This icon is our freewheeling icon. Freewheel, what that does is as we're clamping and we're too far away from the tree, it allows the machine to creep forward until we hit clamp pressure and allows the machine to adjust to improper tree placement. Here is our pad. If we want to turn our sling lube off, we push the button here, sling lube is off. So if we're inside of a shop or inside of an area where we don't want to get water on the floor, we can clamp and unclamp and we won't inject water. This default is for it to be on when you power cycle the machine. So as a technician, if you turn the water off, forget to turn it back on. Once you run a key cycle of the machine, it will default to be on. Actually, both of these default to be on. Now we're going to set clamp pressure. With the machine running, we're going to push setup, and you can see now that it goes to a teal color. We're going to press and hold the clamp button, and the pressure will start to increase. When we turn the wheel to the right, we can raise the clamp pressure. When we turn the wheel to the left, we lower the clamp pressure. The faster we turn it, the faster it moves. So when we want to start to cycle, we will rotate the wheel slower. When we achieve the clamp pressure that we're looking for, we release the clamp button, and now our clamp pressure is set. That is indicated here on the main page, where you can see now that our clamp pressure is at 1464. Next, we have operator adjustment. In here, this is where we get the feel and the control over the rest of the system. So first, we're going to start with the sweeper on time, or with the sweeper on time area. We have a couple different things here. First, we have first only. This machine has the ability to shift when going from tree to tree. So during long spaces, we'll go from first gear to second gear and allow us to increase our advance time on longer spacings. But if that shifting is getting in the way of feel and drift, what we do is we turn first only off, and then it will never shift. First only on would then allow it to shift to a second gear during longer spacings and decrease our time in the field. Next is second only. This is as it applies to the front wheel. So right now, second only is off. Typically, this is going to be on during loose field conditions or when we're trying to load it on a trailer. What it does is it puts our front wheel in a minimum displacement so it doesn't have as much traction and keeps it from slipping in those two types of conditions. Next, we have our sweeper on time. We can adjust sweeper on time two different ways. If we select it, we can take the bar and drag and drop the bar, or we can use the wheel and adjust it on the wheel. What we're looking to do here is the sweeper on time is the time that the sweeper is on once we come to a stop. Typically what we want to do is we want to minimize that time so that way we reduce the ground effect of the sweeper and the overall amount of dust. There's no reason why we're at a standstill to have that sweeper continue to run and run and run and run. A lot of this is also going to be dependent on the speed of the operator. Typically, the faster the operator, the little bit more time it takes for the machine to decelerate. Maybe we want a little bit more time. If an operator is a little bit more tentative, we can afford to have less time, closer to a half a second to 1 second. Next is our sweeper. This is our sweeper adjustment where we can increase or decrease the speed of our sweeper. So 0 is the factory setting. When we go to the right of 0, that increases the speed. When we go to the left of 0, it decreases the speed. So if we're in a younger orchard where we have not a lot of crop to remove, maybe we lower the sweeper value, speed value, so that way we don't take nuts and throw nuts towards the tree. Next, we have acceleration and deceleration. These work on the same principle. These are the feel of the pedal. So we can increase the deceleration once we let off the pedal, and we can increase the acceleration or decrease the acceleration, basically the feel or the sensitivity of the foot pedal for forward and reverse. Next, we're going to go to head control. Head control gives us the ability to control head retract, head extend, head raise, and head lower. Again, this gives us the ability to control the feel of mostly the joystick functions. Lastly, we have clamp control. If this machine was outfitted with a pad lube system, the very top section would be highlighted. It would allow you to adjust your pad lube time. Here is our sling lube time. Sling lube happens every time we push unclamp. Every time we unclamp, we're going to inject water to the pads. This allows us to adjust that time. We typically don't recommend being lower than a half of a second, or typically not much greater than about a second and a half. Usually the sweet spot is going to be between a second and a second and a half of water every time you unclamp. This machine also has the ability, once we push clamp shake and we run a sequence, if we push unclamp one time or twice, it won't inject water. It'll only inject water after a clamp shake cycle. So it helps you reduce the opportunity for wasting water. Next is percent tree released. So on percent tree release, this is the amount that the head is going to open when we're in auto shake. Typically, we want this to what we're looking for is we're looking for the ability to unclamp from the tree so we can retract, but we want it wide enough so when the operator goes to the next tree, he doesn't have to be so tight. So we're kind of looking for a range here where the operator is comfortable in the opening, but what we're trying to mitigate is the time during auto shake. The wider we make it open for trees that are very small, that's wasted time. So if we can open up the head at 50% to shake a bunch of 4 or 5 leaf trees, we're going to save time in our auto. Next to is clamp open and clamp close, and again this is a 0 min max setting. So on the clamp open and close, again, if we go to the right, it's the speed of clamp open and the speed of clamp close, so we can control those too. When pulling up to the tree, it is important to be no more than 8 to 10 inches from the tree as shown on the left. On the right, the head is over a foot away, so when fully extended, it will not reach the pads in the middle. There is an increased wear on the IPX, also a higher risk of tree damage and higher opportunity for cylinder failure. Since the tree is too far away, it is most likely the operator will bottom out the in and out cylinder. If done over and over again, it will cause a failure. Once extended, placing the head in relation to the tree is the next step. On the left shows proper placement of the head to the clamp on the tree. On the right is an example of being too far from the tree, which is incorrect. There is more stress on the tree and the shaker on the right. Also, there is less shake energy being delivered to the tree. We can see the difference in correct tree placement versus improper placement. On the left, the tree is mid-pad and 1 to 2 inches from the tree. If the operator repeatedly has the head too far from the tree, it will have numerous negative effects such as increased risk of barking and damage to trees, higher sling and flap wear and tears, frequent hanger mount and bolt failures and mast damage, reduced shake and less nut removal. With the trees that are leaning, follow the rules listed before in addition to having the head perpendicular to the tree. If the head is clamped as shown on the right, tree damage and hanger bolt can be seen. Lastly, before clamping on the head, attempt to grab the tree in the most uniform spot available. So following these service rules should extend the life and help you get the most out of your equipment you can. If you have further questions, please contact your closest Code dealer.